Well, good afternoon, ladies and gentlemen. I hope you can all hear me clearly. There will be a bit of back from time to time, but we'll try and work around that. Welcome to Airspace. On behalf of the Books of Aviation Society, the British Airliner Collection, welcome to today's nose lowering demonstration. First of all, this aircraft, 101, call sign Delta November, arrived here in 1977. She first flew in December 1971 and took part in a 5-year intensive testing program. One of the main functions was the air intake flaps, which you can see in the front of the engine bays, and that was to control the flow of air at supersonic speed. If it hadn't been controlled, the actual force of the air would have damaged the engines beyond repair and probably brought the aircraft down. So those flaps were extremely important. One of the other functions of this aircraft was de-icing. And if you see on the port or the left-hand wing, the leading edge is painted black and put into sections with numbers and Roman numerals. The aircraft flew behind another aircraft which sprayed water at high pressure. They watched the ice build up through cameras and those were shown on screens inside the aircraft in what was called the ice station. They watched the ice build up, then tested the de-icing equipment to see how effective it was, and also to see whether there was any risk to the aircraft by the ice not being removed. So that was obviously another major function. This aircraft also did slush taxiing trials, where they flooded the runway and then ran the aircraft through to see how it controlled under those circumstances. The aircraft actually took part in trials in North America for the de-icing and in Tangier, because apparently above the equator it's as cold as it is above the Antarctic. And so at the end of the 5-year period, the aircraft was retired to Fulton and then flown here in 1977 on the 20th of August. We've just celebrated the 40th anniversary of its arrival. And 2 days after it arrived, on the 22nd of August 1977, they built the M11 and took a third off the length of the runway. So had we not got it in on the 20th, it wouldn't have been able to land here at all. So that was quite fortunate. For the first 20 years here, it stood outside, and then was the second aircraft to be moved into this hangar when this was built in 2006. The aircraft is maintained by volunteers from the Ducks of Aviation Society, assisted by a group called Heritage Concorde, and they are ex-British Airways and Concorde engineers who turn up once a month and work on the aircraft for us, and they've restored many of the systems, including the nose lowering. Now, why do we have to have a nose lowering? Well, at the moment, the nose is in what we call the zero position, and that is for supersonic flight. So the visor is up, and the visor is there to protect the windscreen at supersonic speed, and so the vision is fairly limited. It's straight ahead, so the flight crew can see a bit, but not a great deal. So for taxiing and takeoff, the nose had to be lowered and the visor had to be lowered. But first of all, so we can illuminate what's going to happen, we'll turn the landing lights on, which is another function that we've restored. So if we can have the landing lights on, please. And you'll see, hopefully, 4 lights coming out from the fuselage, 2 under the nose, which give the visibility. You also see that we've got flashing lights on the wing roots and the wing ends. That's the navigation and anti-collision lights. So once the landing lights are in, we've got 1, 2, 3, 4, 6. There we go. Right, so the first thing we'll do is lower the winds, the shield, the visor, which will then expose the windscreen. So if we can have the visor down, please. Now, if any of you have been to the museum at Yeovilton, the Big Aero Museum, the prototype Concorde is there, and the nose configuration is completely different to this one. This was redesigned by Marshall's Cambridge, because the pilots who flew the prototype felt that the visibility was not adequate. Now, for taxiing on the ground and takeoff, the flight crew, even with the visor down, would not be able to see a great deal. And so the nose will come down to 5 degrees. Nose down to 5, please. And amongst our members in the Doctors of Aviation Society, we have an ex-Concorde pilot, John Hutchinson, and he said it was quite comforting when he sat at the end of the runway to be able to see the far end, so he knew how long he'd got before he had to lift off. Now that was fine for takeoff, taxiing, but because of the aerodynamic shape of the aircraft, when it was coming into land, it came in at a very steep angle. So with the nose down at 5 degrees, the flight crew would still only be looking at the blue sky. They would not be able to see the ground. And so they had to experiment to find a lower angle. And the first one they went with was 17.5. So down to 17.5, please. And you'll see now why we have to put the barriers out, because if you happen to be in that spot when that comes down, it could be quite dangerous. Okay, so that's 17.5. Now that gives great view from the flight deck, but unfortunately the flight crew then can't see the end of the nose, so they lost their point of reference. So that was deemed to be too great an angle, and after various experiments they agreed on an angle of 12.5. So up to 12.5, please. Now this aircraft is unique in the fact that it has these 3 angles of lowering. So 5, 12.5 and 17.5. All the commercial Concordes that were in service only had 5 and 12.5. So this is where it ended up. This is the angle that was deemed to be the most efficient and give the most visibility for landing. And as soon as the aircraft touched the ground, the nose then went back up to 5 degrees. It was not left at 12.5 for many seconds, just the last few yards of approach and the actual touchdown. This aircraft has several unique features. One, as I said, being the nose with 3 degrees of lowering. The other thing is this was the fastest ever Concorde. This aircraft achieved Mach 2.23 on a flight to Tangier, and that's 1,450 miles an hour. Now it never carried any passengers, but it did have 12 tons of computer and test equipment on board. You'd probably get that on a good laptop or an iPad even today, but back in the 1970s, that was cutting edge technology, but 12 tons of it. So it was still a fair weight to achieve that record. It also achieved the record for the fastest, let me get this right, east-west crossing of the Atlantic for a commercial aircraft. Because even though it never carried passengers, it was considered to be a commercial aircraft, and this crossed the Atlantic in 2 hours, 56 minutes. Now the normal commercial flight time from Heathrow to New York was about 3.5 hours, slightly quicker than most of the aircraft today. Now to go back up, first of all we need to come back down, so we can come back down to 17.5, please. You'll see in a moment when we go back up that it actually it comes down a lot quicker than it goes back up. The nose is actually operated hydraulically. You'll hear behind me a pump going, and that pump was made specifically for this task, and it was donated to us by a company called Hydraulics Online, and it powers the nose. That is its sole function. There is no power to the aircraft itself. The electric power comes obviously from an external source. The engines have been removed. One is under the rear of the aircraft if you want to see the engines that were in there, the Olympus 593. Anyway, now we'll go back up to 5 degrees, please. And as I say, it's a lot slower going back up. We're continually trying to restore systems on the aircraft. As I say, we've done the landing lights, the nose mechanism, and at the moment, if you've been on Concorde, or if you're going on Concorde, you will see inside that we've recreated it as the experimental aircraft. So the seats that you see in the aircraft were the original engineers' seats that were in it. They carried around about a dozen engineers around for all the test program. The ice station has been recreated, and some of the computer boxes. The originals were all stripped out of the aircraft before it flew in here, so we have recreated copies based on photographs and drawings, so that when you go on board it is exactly as it would have been the experimental aircraft. The nose back up to 0 now, please. That little click at the end means it's now locked back into position, which means it can't drop down unexpectedly. And now we'll put the visor back up, please. To put things into perspective, if this aircraft were to fly over Duxford today at supersonic speed, in 2 minutes it would be over the centre of London, which gives you a bit of an idea of the speed of it. Okay, ladies and gentlemen, that completes the demonstration for today. Thank you for your attention. Enjoy the rest of your day here at Duxford. Thank you.
See the parachutes.